Today we'll be explaining about the dielectric constant, which is one of our practical experiments, and in this we'll be determining the dielectric constant of a material, of a capacitor, by charging and discharging. Basically, we'll be determining the capacitance of this material which they have given to us. So the circuit goes as follows, like this.
Yeah, so when you start reading a circuit diagram, you do the series connection first and then you connect the parallel branches separately, right? So in the series connection, you can see that the positive of the battery is connected to one side of the key one, right? One side of the key one. The other side of the key one is connected to the resistor. The resistor is here, okay? Let's call it the positive of the resistor, right? And now, next, the negative of the resistor is connected to the positive of the capacitor. That's already done. See, the series connection between, you can see this as a series connection between resistor and capacitor. That's already been done here, right? Now, the negative of the resistor is connected back to the battery. So the negative of the capacitor, negative of the capacitor will go back to the battery. Now let's do the connections. So positive of the battery is going to one side of the key, right? This side of the key. Now this side of the key is connected to the resistor, okay? Resistor. This side, the other side of the key is connected to the positive of the resistor, this part. Now the negative of the resistor is connected to the capacitor, and the capacitor is negative. This is the capacitor's negative. That's connected to the negative of the battery. So now the negative of the capacitor, right, is connected to the negative of the battery. Negative of the source, right, is here. Negative to negative. Now what we have to do? We have to connect the parallel connections. So the first parallel connection is across the capacitor. So this is across the capacitor, right? If you see here, this is the positive of the capacitor. The one in junction between resistor and the capacitor is the positive of the capacitor, right? You see the circuit diagram. Now the positive and negative, between them, I'm going to take a voltmeter connection, right?
This is negative.
So this is the negative. The negative will go to the negative. Where is the negative? The one that's connected to the battery. That's the negative of the capacitor, right? And the positive of the capacitor is the one in between resistor and capacitor, right? So now we did the first parallel connection. The second parallel connection, it is between the other side of the key. See, this side of the key is connected to the battery, right? The other side of the key in the circuit diagram and the negative of the battery. So this side of the key and the negative of the battery, I have to take a parallel connection and connect it between the other key. Okay, I'll take the other key. I have to do a parallel connection between one side of the side of the key that's not connected to the battery, right? This side, that comes on one side. The other side is going to the negative of the battery. These are the connections. Now Vishnu will explain the experiment. He will explain the significance of this graph and the experiment.
So as the circuit diagram connection is done over here, now I'll explain how the experiment works. And before starting the experiment, you should ensure that the voltage is set to be 3 volts. Before setting it to 3 volts, please make sure that there is no connection or the key should be open. If it is closed, the capacitor will get charged and you might get the wrong readings. So set it to 3 volts.
So make sure it's in volts.
Yeah.
The volts is
outside.
So this light should glow. It should. You use this button to change it from amps to volts, right?
Not amps.
And volts. It should be in volts. You can use the fine and coarse adjustment to get the correct value.
So as the voltage is set to 3, now look at the multimeter. Even this should be 0. In order to make it to 0, use the wires and short it over here at the capacitor. Look at there, it becomes 0.
So the explanation to this is that this voltmeter is connected across the capacitor, right? Now if there is potential difference across capacitor, then it will show voltmeter reading. Now by connecting the two ends, we are shorting. So basically whatever potential difference is there will be charge flow and all the potential difference will be gone. That's why it's 0.
And these are the things which you should do before starting the experiment. And the first part of the experiment is the charging part. in order to the capacitor to get charged, you should plug in the key 1. The key 1 over here is this one. Plugging in, and as soon as you plug it in, you should start the timer.
Discharge it. You've already
And
lost
look at the readings, and at proper intervals like 25 seconds, 50 seconds, you should take the reading of the voltage at correct intervals.
So now at every 25 seconds you will take reading.
Take the readings.
Right, we'll wait for it to at around 500 seconds, right? So 25 seconds, 0.62. That's what you'll write.
Here it will be 0.62.
So basically we'll wait till it reaches around 600 seconds, or else we'll wait until this reaches its maximum value. So it'll become constant in its maximum value. We'll wait till
You
then.
should at least get 3 constant values. Till then you can't skip the steps.
So we'll wait till then. So while this charges, we'll just see in the diagram what's actually happening in the circuit. So now, as we know, we plug the K1, right? So this circuit is closed. So and K2 is open. So it's as if this branch is not existent at all. Now what's happening is charge is flowing in this direction, positive charge, or electrons are flowing in this direction, and they're accumulating on this plate of the capacitor. So what's happening is there is a potential difference that's building with respect to time, right? So that's what's happening during the charging. So it has almost reached the maximum value. So it's constant at 2.82. Now what we'll do is, as soon as it reaches a constant value, we'll stop the clock.
Note down the maximum value, the constant value, whatever you have got.
Reset it, and then put key 2 and start simultaneously. Right? Now you see it rapidly
discharging
decreases.
graph. You'll get this discharging graph from this point.
You will
So
not-
you need to go till 0.01 to the least value. To the least value, and
So one thing you should notice, your maximum value
Should
and the first
be-
value here should be the same thing, obviously,
the
right?
same thing.
Yeah. So you see every like 25 seconds, it's rapidly decreasing first, and then it will gradually decrease. Around 600 seconds, it has almost become 0. Now for the calculation,
here you can see the formula. Epsilon r equals to 10 power minus 6 d. T half is the time constant, that is the time required for the charging or discharging to the half of the maximum potential, and A is the area of the capacitor, and R is the resistance what you have applied here. Epsilon naught is the permittivity in the free space. These are the values D, A, R, and these stuff will be given to you on the board, which you have to note down. A would not be given, instead they would have given you the length of the dielectric medium and the breadth. Obviously you can just calculate it using the area formula, and just substitute the values in the given formula. You'll be getting the answer as 1.852, and it ranges between 1.5 to around 2. So the from graph you will be getting the time constant value, T half. This T half is, you would be substituting T half over here. T half is something what you will be finding out in the graph, and the rest of the values will be given to you, and A will be given in terms of length and breadth. You should calculate A by yourself.
so basically in the graph there is a growth curve and there is a decay curve, right? The intersection point, you see what time is corresponding to the intersection point. That's your T half. So if you're wondering what half is, you see that the maximum current here is around 2.9, right? The minimum half current is, you see, it's 1.45. So it's half of the maximum current. So you have to see the value of time corresponding to half of the maximum current, right? And happens so that it's the intersection point of the growth and decay curve.